This is 3.2 notes for Algebra 1 on CBR and slope in real-world situations. CBR is a little contraption that's called a calculator-based ranger. That's where the term CBR comes from. Calculator-based ranger. And what it is this little contraption here that we can hook up to our calculators, and it graphs things based on time in seconds down at the bottom, and then distance from the CBR over here on the y-axis. So if we assume that this is 0 in terms of time before we start, and this is 0 feet away from the CBR, or meters. You can do it in meters or feet. I think in this lesson it's all done in meters. So let's say a person starts right here. That would be 2 meters away from the CBR. And then we hit start, and then they can start walking. So if they walk kind of at a steady pace, it'll go like this. If they speed up, it's going to get taller. If they slow down, they go like this. So if they start coming back toward the CBR, it's going to come this way because it's going to calculate the distance from the CBR. Okay, so let's look when you, again, just if you start, let's say you start further away. If you start over here and then walk toward the CBR, you're going to come this way. If you stand still, and if you start walking away from again, because this is distance from the CBR, so as you come toward it, it's going to get closer. As you walk away from it, it's going to get further away. So here's a graph right here. It says, how far did the person start? Well, it's on the 2 slot, so that's 2 meters. Was the person moving toward or away from the CBR? Well, it's going this way, so it's getting further and further away, so that's away. What kind of pace? So what we're saying there is, did he change how fast he was going? And it's no, he was going at a steady pace. It says sketch the graph if you stood still. If he stood still and started right here, it would just go like this. Nothing would happen. And then sketch the graph if after 6 seconds he began to walk faster. I'll do that in orange. So 1, 2, 3, 4, 5, 6. So right about here, if he started to walk faster, the graph would start going up like that. Okay, because he's getting further away at a faster pace. So that's a CBR, and in class we were able to kind of practice with one a little bit, but since you're only getting this in the video, unfortunately you don't get to see it. Okay, now let's look at some real-world slope situations. So it says, identify the independent and dependent variables, then find the slope of each line and tell what it represents. Okay, here's a tip. Anytime you're asked to find independent and dependent, independent is always the x, and dependent is always the y. So in this case, the independent variable is the boxes sold. The dependent variable is the amount of profit. Now, what is the slope? You have to be careful in real-world situations because the scale on your graph may change. But let's look here. We want to find the slope. So I'm going to use the 2 points they gave us here, and we're going to do rise over run. So we went on the y's, we went from 4 to 8, that was up 4, and then we went from 2 to 4 on the x's, so that's over 2. So the slope is rise over run, and that's 4 over 2, so there's a slope of 2. Now, let's call it 2 over 1. Now, it says, what is the meaning? This is the procedure you need to use to figure out the meaning, because remember, slope is the change in y over the change in x. So let's put the words for the y. The y is profit over the words for x, which is boxes sold. So if you have 2 over 1 slope, and profit is going to be in dollars, okay, that means you get $2 profit for every box of popcorn sold. It says boxes of popcorn up here. So for every box of popcorn sold. And you see how we figured that out? Just by using the words of the slope. Profit over boxes. 2 for the profit, 1 for the boxes sold. Okay, let's try the next one over here with the plant. It says plant growth is the title, and we have the height in centimeters and the time in days. Independent variable, always the x, so that's time in days. Okay, dependent variable, always the y, so that's height in centimeters. Now, what's the slope? Okay, here's one where you have to be careful because each one of these little slash marks is going up by 2, not by 1. So you have to make sure you calculate it correctly. Well, let's just use the points that they gave us here. We're going from here, we're going from 10 up to 20. So that's a difference of 10 on the rise. And on the run, we're going from 30 to 50. That's a change of 20. So the slope, y over x, 10 over 20, would be 1/2. Okay, so now let's figure out the meaning. Now remember how to do the meaning? Change in y over change in x. Let's use the words. Height in centimeters over time in days. So we have 1 over 2. So just look at your words. This plant is going to grow 1, let's write it. The plant grows 1 centimeter every 2 days. So that's how you figure out the meaning of the slope. Put the words for the y over the words of the x and then write it out like that. Okay, let's go to the back. Okay, it says some employees of Ace Corporation left their office building and drove separately on the same road to a convention. The graph shows the distance traveled by each employee after 5 hours of nonstop driving. Okay, so, and they're all going 4 different speeds. And we can tell they're going 4 different speeds because the slopes of the lines are all different. So, and I can tell you that Mr. Ruiz is going the slowest because he's going the least amount of distance. See, when he gets here, he's only gone 100 miles, whereas Mr. Abel has gone 170, and Mr. Hill, oh, he's gone way up here. And Mr. Wu, see, because his line's steepest, we know that's the one that's the fastest. Okay, so anyway, what are the independent and dependent variables? So x is always independent, y is always dependent. So x is time in hours, and this is distance in miles. Now it says, what is the slope of Mr. Abel? Okay, well let's look. We need to find 2 perfect points. So I'm going to use this one right here. 10, and that's 125 right there. And 0, 0. How are those for 2 good perfect points? So we have 0, 0, and then 10, 125. So let's find the slope. The change in y is 125 over the change in x is 10. Well, he's going at a whopping 12.5 miles per hour. It's not very, it must be on a bicycle or something. What is the slope of the equation that models this situation? Well, the equation is going to be this. Well, first of all, let's put the 12.5, and then the equation we would write is y equals 12.5x, okay, because it starts at the origin, there's no plus or minus. And now what is the meaning of the slope? So the meaning is y over x, miles over hours, and he's doing 12.5 for every 1. So he's going 12.5 miles per hour. Okay, let's look at number 6. A small business purchased a van to handle its delivery orders. The graph shows the value of the van over a period of time. Which of the following best describes the slope? Okay, well, let's figure out the slope. First of all, we see it has negative slope. So if this is the value of the van, we know the value of the van is decreasing. honestly, I think without even figuring out the slope, we could answer the question, because let's see what we've got here. It says the van was purchased for $1,600. Remember, the y-intercept is what we start at, and it's not 1,600, it's 16,000 right there up at the top. So it's not that. The van decreases, this is a possibility right here. The van increases in value, no way. It's going down by the line. The van has no value after 5 years, so let's go up here to 5 and over. Well, it's worth $8,000. So there we go. So it has to be this one. Okay, now for the last question, why don't you try it and see what you get, okay? Try this one yourself and see how you do on it, okay? Hit pause. Do it yourself. Try. Okay, so I hope you've answered D for number 7. Now the way I figured it out was to take this point and this point, and so we had 0, 1,500 for the first point, and then 180, comma 0 for the second point. Then I found the slope. From 1,500 down to 0 is minus 1,500, and from 0 to 180 is plus 180. Divided that, and so ended up with a slope of negative 8.33 over 1. Now to figure out the meaning, you always want to use the words, the y word on top, the x word on bottom. And so this is the altitude in feet. So negative 8 is the feet, and 1 is the second. So this answer right here, letter A, that's one to throw you off, because it says the plane descends 1 foot every 8 seconds. So that's the opposite. So that's trying to get you to answer one that's wrong. The correct answer was D, because he's going down 8 feet per 1 second, not the other way around. Okay, so there you go. That's how you figure out the meaning of slope. Use the words, the y words on top, the x words on the bottom, and you will have your meaning. Okay, good luck. See you in class.